بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 1.2, Mathematical Models, a catalog of essential functions. I will solve first example 5 in the book. Find the domain of this function. We have a fraction, so we do not accept that the denominator is 0. So let us find what makes the denominator 0. If we put the denominator 0, we can take 2 cosine x to the other side. So 2 cosine x would be equal to 1. Or you can keep negative 2 cosine x here, take 1 to the other side, it would be negative 1, and then multiply by a minus sign. So cosine x would be half. So all x values that make cosine half will make the denominator 0. Now, how to find all x values that make cosine equals half? I suggest that I use the calculator. If I use the calculator to find cosine inverse half, okay? So if you use the calculator to find cosine inverse half and make sure that the calculator is in radian mode, the answer would be pi over 3. The calculator will give you one of the solutions of this equation. But as we know, cosine is a periodic function, which means if pi over 3 is a solution, then if you add any multiple of 2 pi, it would be also a solution. So in fact, the solution would be pi over 3 plus 2n pi, where n is an integer. So n belongs to z, where z is the set of all integers. But unfortunately, these are not the only solutions, because also cosine is not one-to-one function. So sometimes two different values of x will give the answer cosine of x would be half. So how to find the other answer? Well, to find the other answer, we need to sketch the graph. The angle pi over 3 is here. This is the angle pi over 3. Now, if you remember the reference angle, okay, I need all the angles with reference angle equals pi over 3. So in fact, we have another angle here, which is 2 pi over 3. This angle has a reference angle of pi over 3. This angle is pi over 3 because this is 0. From 0 to here, this is pi. And pi is 3 pi over 3. So the reference angle is pi over 3. Subtract pi over 3 from pi. You get 2 pi over 3. There is also this angle, which is 4 pi over 3. And you get it by adding pi over 3 here. So the reference angle of 4 pi over 3 is also pi over 3. And there is another angle, which is 5 pi over 3. This angle has also a reference angle of pi over 3. So I have 4 angles with reference angle equals to pi over 3. Pi over 3 itself, and 2 pi over 3, 4 pi over 3, and 5 pi over 3, because this is 0, and at the same time, it's 6 pi over 3. It's 2 pi. So as we know, cosine of these 4 angles is either half or negative half. If you remember, we have cosine, we need it to be positive. Well, cosine is positive in the first quadrant and in the fourth quadrant. Okay, we can use all students take calculus. C is calculus from cosine, so cosine is positive here and here. Or you can remember that cosine follows the sign of x. So if cosine is positive, it would be positive where x is positive. So it is positive here and here. So what does this mean? Pi over 3 is a solution. We found it by the calculator, but the answer that the calculator does not give is 5 pi over 3. So in fact, 5 pi over 3 is also an answer. I mean, if you use the calculator and ask the calculator to give you cosine 5 pi over 3, the answer would be also half. So x equals 5 pi over 3 is an answer. And if you add 2 in pi, because cosine is periodic, so you will get more and more answers. So in fact, all of these numbers, okay, these numbers, these values of x and these values of x, all of these values of x, their cosine is half. So what would be the domain of the function f? The domain of the function f would be all real numbers minus these values. So minus pi over 3 plus 2n pi and minus 5 pi over 3 plus 2n pi, where n is an integer. And that would be the answer of this question. Another similar example, it's not that similar, but with trigonometric functions. Again, we have a fraction, and we do not accept that the denominator is 0. So if you take sine x to the other side, sine x would be 1. Any x value that makes sine as 1 shouldn't be in the domain of this function. So we have to search out where sine is 1. Here I suggest that we use the unit circle. The unit circle, I know that this point has coordinates 1, 0. This point has coordinates 0, 1. This point negative 1, 0. And this point 0 and negative 1. For the in the unit circle, cosine x is just, let me say cosine theta, okay? Cosine theta is just x, the x coordinates, and y is sine theta. Because generally, the definition of cosine theta is x over r, but r here is 1 because the radius is 1, the unit circle. So I mean, now this angle is 0. This angle is 0 or 2 pi. If you go like this, it's also 2 pi. This angle is pi over 2 from here to here in a standard position. And this angle is pi also if you graph it in a standard position. And here, this angle, if you go like this, is 3 pi over 2. So if you need to find cosine pi over 2, for example, it's the x coordinate, it's 0. You can check by the calculator. Sine pi over 2, it's 1. Okay. Cosine pi, negative 1. Sine pi, 0, and so on. So I need the angle that makes sine 1. Sine is y, and it is 1 only here. Okay, because y here is 0, y here is 0, y here is negative 1. So the only angle that has sine equals to 1 is pi over 2. Of course, if you use the calculator to find sine inverse 1, it will also tell you that the uh, the answer is pi over 2. But as you have seen here, the calculator doesn't give you everything. It gives you one answer. So how to make sure that this is the only answer? I need this figure, okay? This figure tells me that pi over 2 is the only angle with sine equals to 1. Good. Now, since sine is periodic, so if you add 2 over 2 pi, 2 pi to this angle, you will get another angle that with sine equals to 1. So the solution of this equation is pi over 2 plus 2 n pi, and n is an integer. So what would be the domain of the function f? It would be all real numbers except these numbers, because these numbers will make sine 1 and then the denominator will be 0. So that's the solution of this problem. Remember that z, set of all integers, consists of 0, 1, 2, and so on up to infinity, and -1, -2 up to infinity. So n could be positive or negative. You could go in the positive direction or in the negative direction. Another example, uh, we do not accept that 1 minus tan x equals 0, which has a solution tan x equals 1. So all the values of x that makes tan as 1 should be removed from the denominator, the domain of this function. Well, how to find out where tan x, which value of x makes tan 1? You can use the calculator to find tan inverse 1, and it would be, you will find that it is pi over 4. Okay, is it the only solution? How to find out? I need to sketch the graph using reference angles, but now all angles with reference angle pi over 4. So I have this angle pi over 4 itself. It has a reference angle of pi over 4, and I have this angle with a reference angle also pi over 4. If this is pi, it is 4 pi over 4. If you subtract the reference angle, which is pi over 4, you have 3 pi over 4. So this angle, the measure of this angle is 3 pi over 4. Also, I have this angle, which is 5 pi over 4, with reference angle also pi over 4. And I have this angle, which is 7 pi over 4, with reference angle pi over 4. So all of these four angles are pi over 4, and these four angles has reference angle equals to pi over 4. So according to a theorem, they have the same tan except possibly for the sine, which means that the tan of these four angles could be positive or -1. Well, we need it to be positive. So where is tan positive? All students take calculus. So tan is positive in this quadrant and in this quadrant. So the solution of x that's given by the calculator, pi over 4. And of course, it is pi over 4 plus 2n pi, because it's periodic. But also 5 pi over 4 is a solution which is not given by the calculator. So 5 pi over 4 is also a solution, because tan 5 pi over 4 would be 1. So how to write all of these solutions? Pi over 4 plus 2n pi, let me write them here. I have pi over 4 plus 2n pi, and I have 5 pi over 4 plus 2n pi. Can I write these solutions uh, in one line? Okay, the answer is yes. Why? Because the angle between pi over 4 and 5 pi over 4 is what? From here to here, it is pi. Okay, from here to here, pi. Which means if you add pi to pi over 4, you will get to 5 pi over 4. Another pi, you will get to pi over 4 plus 2 pi. So if you just say pi over 4 plus n pi, this will give you all of these solutions together. You start by pi over 4 and adding a multiple of pi. Pi, 2 pi, 3 pi, 4 pi. You will get all of these together if you just write pi over 4 plus n pi, and n is an integer. Good. So these angles must be removed from the domain of G. But I have another problem in this question. Tan x itself. Tan x, the domain of tan x is not all real numbers, because tan is sine over cosine, and cosine is in the denominator, so it cannot be 0. So I have to find out where cosine is 0. Well, if you look here to this figure, cosine is x. Where is x 0? X is 0 here and here. So cosine pi over 2 is 0, and cosine 3 pi over 2 is 0. And the angle between pi over 2 and 3 pi over 2 is pi. So I can say that cosine x equals to 0 at, or when, okay, I write at, x equals pi over 2 plus n pi. So pi over 2 and adding pi, another pi, you will get all of the solutions of this equation. So the domain of this function g will consist of all real numbers except pi over 4 plus n pi, because these values will make tan equals to 1, and this will make the denominator 0. And I have also to remove pi over 2 plus n pi, because these values will make tan not defined, because they will make cosine 0. So if I ask you to find g of pi over 2, 1 over 1 minus tan pi over 2, but tan pi over 2 is not defined. So I cannot find g of pi over 2. So pi over 2 must be excluded from the domain of this function. So this would be the domain of g. Another type of questions, find a formula for a cubic function. Well, cubic function, has this form: ax cubed plus bx squared plus cx plus d, and it should have three roots. Okay, three roots. These three roots, or three x-intercepts, these three roots or x zeros or x-intercepts could be different, could be equal. So let us look here. Find a formula for a cubic function like this. If f of 1 is 6, so this is one information, f of 1 of 6, this means that this function passes by the point 1 and 6. If -1, f0, f2 are zeros, okay, so I have points -1, 0, 0, 0, and 2, 0. What are these 3 points? In fact, these are the x-intercepts. Okay, if you sketch, this is -1, 0, this is 0, 0, this is 2, 0. So these are the 3 x-intercepts. They make the function 0. Okay, so I can say that the function f of x equals a, which is the leading coefficient, times x minus the first 0. -1 is a 0 of this function, because we have -1 and 0. So if you replace x by -1, y should be 0. Okay, so x minus minus 1, or x plus 1, is a factor of this polynomial. And also x minus 0 and x minus 2. So since the three x-intercepts are given here, so we know that f of x must have this form. I can write it a. We don't have to write x minus 0. I can take x here and then times x plus 1 and x minus 2, and it remains to determine the value of a. Well, I can use this point to determine the value of a. What does this point say? It says if x is 1, y is 6. So y, what is y? Y is f of x. So 6 would be equal to a times, and replace x by 1. So a times 1, 1 plus 1, 2, 1 minus 2, negative 1. So 6 is negative 2a. So a would be 6 over negative 2, which is negative 3. So the function is negative 3 times x plus 1 times x. Okay, I will write x first. So it's negative 3x times x plus 1 times x minus 2. That's the cubic function that satisfies all of these. So for example, if you put x0, put x0, y would be 0. If you put x2, put x2, y would be 0. 2 minus 2 is 0. 0 times anything is 0. Okay, so this function will satisfy the four conditions. The last question, this is a relationship between the Fahrenheit F and Celsius temperature scales. Now sketch a graph of this function. Well, what C and in instead of x, f instead of y. Here f is written as a function of c. If you want to graph this function, this axis would be the c axis and this axis would be the f axis. The y-intercept is 32. Okay, so you can start by the y-intercept 32. Let me say that this is 10, 20, 30. So 32 is somewhere here. So this is the y-intercept. This is 10. Okay, I'm going 10 units. Now, how to use the slope to sketch the graph of this line to find another point. This is the change in y over the change in x. So if or change in f now over the change in c. So if you go 5 units from this point, this is 10, if this is 10, so 5 points would be here, okay, to the right, and 9 points up if this is 10 and this is 10, so 9 points up would be here. So you reach this point. So 5 units right, 9 units up will give you another point on the graph of this line. So you just now connect these 2 points and this will give you the graph of this linear equation. Okay, you can find, if you like, the x-intercept. You can check out what the x-intercept is. Okay, how here it is the c-intercept. You put f 0, you put f 0. So 9 over 5c will equal to negative 32, and then c will equal to negative 32 times 5 over 9. If you use the calculator to approximate this number, it is approximately 17, negative 17.8. So see, this is, if this is 10, this would be 10, and this is the other 10, and you can say that the x-intercept now is correct. So it here it is approximately negative 17.8. So this is the graph of this function. What is the slope of the graph? The slope of the graph is 9 over 5, isn't it? 9 over 5. What does it represent? It represents what? If you increasing C by 5 will increase F, the Fahrenheit scale, by 9. So if you that what we used here. If you increase the scale C, if you go to the right, increase C by 5, F would be increased by 9. This is the meaning of the slope. What is the F-intercept? ال F-intercept اللي هي instead of the Y-intercept, ال F-intercept is 32, which we used to graph 32. Okay, what does it represent? Well, the F-intercept means if C is 0, F is 32. So that's the meaning of the F-intercept. If C is 0, if the Celsius scale is 0, then F is 32. The Fahrenheit scale is 32. So when the Celsius scale is 0 degree, the Fahrenheit scale would be 32 degree. This is the last question. So thank you very much and have a nice time.